Hello everyone, you are welcome to Jewel Study World. Today our lesson will be on Covalent Bond Part 2. So now let's check this example. Nitrogen molecule. We have already learned the part 1. If you missed it, just pause the video, go and watch the part 1, and I'll come and continue from part 2. So now, for a bond to be formed, the atoms, the reason why atoms form bond is that they want to become stable. For stability, you have already learned all of these. For stability. Now, for covalent bonds to be formed, the atoms must share electrons. Unlike the ionic bonds where atoms transfer electrons, for this one, the atoms share electrons to become stable. Let's check nitrogen molecule. It has 2 atoms of nitrogen. So let's write the configuration. It's number 7. So you get 2, 5. So nitrogen molecule has 5 electrons in the last shell, but it has to get 8 electrons in the last shell to fulfill the octet rule, which says that for the atom which has more than 1 shell, it has to get 8 electrons in the last shell for it to become stable. So you have two atoms of nitrogen here. So let's draw the atoms showing only the last shell. So you get nitrogen here with only the last shell, which has 5 electrons. So you have 1, 2, 3, 4, 5. Only the last shell. You have 2 of them. You also have another nitrogen here with only 5 electrons in the last shell. 1, 2, 3, 4, 5. So this guy needs 3 electrons to add up to the 5 electrons to get 8 for it to become stable, to fulfill the octet rule. The same thing applies to this one too. It needs 3 electrons to be added to the 5 electrons to become stable. So now what they will do is that they will share the electrons. How will they share the electrons? Since this guy needs 3 electrons and this guy also needs 3 electrons, let's rearrange it too, so that they do the electrons perfectly. So now let's bring this electron here, then this one to here. So now they will share these electrons, 3 here and 3 here. How will they share the electrons? It will be like this. Now this guy has 8 electrons and this guy has 8 electrons. They have 1, 2, 3, 4, 5, 6, 7, 8. Now this guy is stable, and this guy too, you have 1, 2, 3, 4, 5, 6, 7, 8. So now they are both stable. Let's show it much clearly. So you have N here with 6 electrons, 5, 1, 2, 3, 4, 5, and N here with 1, 2, 3, 4, 5. So since they are sharing electrons, this guy will have 8 electrons here. So you have 1, 2, 3, 4, 5, 6, 7, 8. Now this guy is stable because it has 8 electrons in the last shell. It has fulfilled the octet rule. And this guy too is also stable because it has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its last shell. Now it has also fulfilled the octet rule. Now they are both stable. Since we have 3 pair of electrons or 3 shared pair of electrons, these electrons here in the middle, which are being shared, is called shared pair of electrons. It is called shared pair of electrons. So since you have 3 shared pair of electrons, note that 2 of them will form just a pair. So we have 1, 2, 3. 3 shared pair of electrons. So you get 3 covalent bond or triple covalent bond. So we get N and then N here, which has triple covalent bond. So it means that nitrogen forms triple covalent bond, or nitrogen molecule form triple covalent bond for it to become stable. So N will form triple covalent bond to become stable. Now they all have 8 electrons in their last shell. Let's check this example too. So let's check the bond between water molecules. So the formula for water is H2O. Here you can just even know how the bond will be like by just knowing how it will be arranged. You have to know the central atom, because the rest of the atoms are forming the bond to the central atom, and the central atom is mostly the one that has the least number of atoms. So here H has 2 atoms and O has only 1 atom. So it means that the central atom is oxygen. So you have oxygen here. H is forming a bond, or H forms bond with 2 H atoms. So you have 1 H here and then 1 H here. So this is how the structure will be like. So now since you know how it will be like, the bond will become very simple for us. So we have O here and H here and H here. Also H, or hydrogen atom, has only 1 electron in its shell. So it has only 1 electron in its shell. And oxygen atom has 6 electrons in its shell. So it has 1, 2, 3, 4, 5, 6 electrons in its shell. So H wants to become stable by having 2 electrons for it to fulfill the duplet rule, and O, or the oxygen, wants to become stable by having 8 electrons in its last shell for it to follow the octet rule. So what will they do? This one will share these, then this one also will share these. Now H will have 2 electrons in the last shell. O will have 8. 1, 2, 3, 4, 5, 6, 7. You have 1, 2, 3, 4, 5, 6, 7, 8. Now O is stable. And now H, you have 1, 2. It's also stable. So now let's draw it much clearer. We have H here with 1 atom, one electron here, and O with 6 electrons here, and H with 1 electron here. So now this H will have, since they are sharing electrons, this H will have 2 electrons here for it to become stable to fulfill the duplet rule. And now here too, this O will have 8 electrons here. You have 1, 2, 3, 4, 5, 6, 7, 8 to fulfill the octet rule, right? And now H here will have 2 electrons, 1, 2, to fulfill the duplet rule. Now it will be like this: H here, O here, and then H here. Here we have just a pair of electrons, or a shared pair of electrons, just one. So you have 1 shared pair of electron here. So now these will form just a single covalent bond, and also have 1 shared pair of electron here, which will form a single covalent bond. Now this will be the structure showing the covalent bond between the water molecules. Water forms a covalent molecule or a covalent bond because it consists of only nonmetals. Because for covalent bond to be formed, the atoms that have that bonding, they must be only nonmetals. Let's check our last example. So our last example, methane molecule. Once again, let's check our central atom, because the rest of the atoms are forming a bond with the central atom. The central atom is the one with the least number of atoms. So C has 1 atom, H has 4 atoms. So it means that C or carbon will become the central atom. So you have C here. Then it's formed bond with 4 H atoms. So you have 1, 2, 3, 4. You have H here, H here, H here, H here. So this is how the bond will be like. Now let's continue with it. So let's draw or show how the bond will be formed. So you have C here, H here, you have C, carbon here, forming bond with 4 hydrogen atoms. Carbon is number 6. So 6, you have 4 atoms in the last shell. You have 2, 4. So 4 electrons in the last shell. It has to get 8 electrons for it to become stable, to fulfill the octet rule. Since it has 4, it needs 4. So now it has only 4. 1, 2, 3, 4. And 8 has only 1 electron in the last cell. Only 1 electron. So now what do they do? How will they bond? This H will bond with this to get 2 electrons in the last cell. Now the H is stable. This H2 will bond with this. Now the H is stable. It has 2 electrons. Now this one too has 2 electrons in the last cell. This one too will have 2 electrons. So now they are sharing electrons. And now the carbon also will get 8. 1, 2, 3, 4, 5, 6, 7, 8. Now carbon is also stable. Now they are all stable. Let's show it clearer. So you have 8 here. We have carbon C. You have 8, 8, 8, 8. To be like, because you have just one shared pair of electrons here, which forms just a single covalent bond here. The same thing here too. You have just one shared pair, then just one shared pair, just one shared pair here. So now this is how to solve for the bond between nonmetals. Check the other examples on the screen. This is Jewel Study World. You are welcome to study with us anytime you want. You have to like, share, and subscribe.